Hello, in this video we're going to be talking about the end behavior of polynomial functions. Do they end up or down or some combination in between? In order to determine the end behavior, what we need to do is we need to check the degree and the leading coefficient. A quick reminder is that the degree is the highest exponent when the polynomial is in standard form, and the leading coefficient is the number that is with that term that has the degree's exponent. Thing. So if our leading coefficient is positive and our degree is odd, so like 1, 3, 5, 7, whatever, then what's going to happen is our two endpoints are going to go up and then the other end will be pointed down. I don't know what's going to happen in between, so there could be a curl like that, there could be a bunch of wobbles, and then there's that, or they just kind of connect together. But I do know that the start will be down and the end will be up. If it's odd, it's that same thing, but in reverse. So it starts pointing up on this end, and on this end, it is pointing down. Again, there could be some wobble like that. They could go straight. There could be lots of wobbles, but we know that in between those two, it should start high and then end low. If it was even, if that degree is even, so 2, 4, 6, 8, 10, 12, then our leading coefficient is positive. In general, at the beginning, we're going to be going up and ending up. You can think about like a quadratic. A quadratic, if we have a leading coefficient that's positive, it makes that U-shaped graph. Whoop. But in general, all even degree polynomials will do that if their leading coefficient is positive. They might have more wobbles in between, but they'll start and end high. If our leading coefficient is negative and our degree is even, then it's like a frowny face quadratic. So kind of like pointing down, and it'll kind of wobble around like that. But it could just go whoop, just straight there. But we do know it's going to start and end low if the leading coefficient is negative and the degree is even, and will start and end high if the leading coefficient is positive and the degree is even. So let's try that out. I've got a couple examples here, and I want to see what my graph is going to do. So in the first one, the degree is odd because I've got that 3, and my leading coefficient is positive. Since the degree is odd, it's going to be opposite directions, and in general, it will be going up. So it's going to start down low, and it should end up high. So if I check my graph, sure enough, as it graphs it, it started down low, it went up and then down low again and made this big kind of curl like that, but it did follow that pattern, starting low and ending high. If I check this one over here that has a degree that is even, and the leading coefficient again is positive. So I know in general, since it's even, they'll either both be up or both be down. Since the leading coefficient is positive, they're both going to be up. So I should see a graph that looks something like this. Let's confirm that. I'm going to turn off that first one and turn on the second. And when I graph it, I can see, okay, it went low. Oh, it did a little wobble there in between, but then it ended up high. So it did sort of follow that pattern of starting high and ending high, even though there was sort of a wobble in between. Now, in these next two examples, what I'm hoping to see is like why this matters. So if I look at this problem right here, my degree is even, and now my leading coefficient, that negative 0.5, is negative. So since it's even, it's both up or both down, and since it's negative, it's both going to be down. So I should see a graph that looks something like that. I don't know what it's going to do in between. However, when I graph it, the thing that the graphing calculator comes up with is this thing. And I'm like, hey, where's the point where it comes back down? I can see here that it's going down, but I should see another coming down over here. I don't see that. That's because my window isn't showing me everything. So having this knowledge helps me understand, like, okay, well, what are all the things that I should see in my graph? I know that even though this thing is shooting up right now, it's gonna come back down some point. So I'm gonna adjust my window. I'm gonna say it's more to the X max side. So I'm gonna increase this to 20. And now when I graph it, oh, there it is. There's where it comes back down. So it did that wobble that it just did, and then it comes back down over here. So this graph will look something like that if I were to write it down on paper. And I knew that this part was going to show up. Now in this next example, we can see something similar. This is the same as the previous one. However, I've changed the sign on it so we can get an idea of, hey, what happens when we just change that leading coefficient. So if I change this, make this negative, and make the other part negative, we should see that same graph, but it's just going to be flipped upside down. Instead of starting and ending low, we should start and end high. So if I graph this thing, the only change I expect to see is that it flips over. There we go. Since the degree is even and the leading coefficient is positive, this thing must start and end high. So I'm going to make a little graph. And it looks something like that. It doesn't need to be perfect. And that's the rundown of end behavior. If our degree is odd and our leading coefficient is positive, in general, it will make kind of this upward line. As x is approaching negative infinity, f of x approaches negative infinity, as well as f of x approaching positive infinity, x approaches positive infinity. Degree is odd, in general, goes down. If it's even, the degree being even, they're either both up or they're both down. If that leading coefficient is positive, kind of makes that U-shaped graph. It could have some wobbles in between. And if our degree is even, but it's negative, it's going to make that sad U shape. And again, with all of these, we just know how it starts and ends. There could be all kinds of wobbles that happen in between, but we do know the start and the end of the polynomials graph. And that's it. Thanks for watching. Goodbye.